All right, guys, so most of you guys are public works, right? All right, good. All right, guys, I want to welcome you guys to the live wire electrical safety demonstration here. You guys are actually the first crew to actually get to see this. So this is a brand new trailer. We actually built 10 of these for every operating company in First Energy. So they're all over from Jersey, Ohio, several in Pennsylvania. And the goal of these is basically we're taking around to public works, first responders, EMS, anybody that's basically has to deal with our utilities. So you guys know, I'm sure you guys all have stories. You get out, you're over on major storm hits, you guys are out there, you got high lifts, whatever, you're cleaning trees up. I'm sure you guys have been out there, you see trees on power lines, they're on fire, stuff like that. So we're gonna kind of give you guys a demonstration on basically how to keep you guys safe and show you things that you normally don't see. Normally you don't see electricity, you don't hear it, none of that stuff. So today you're gonna actually get to see some arc sparks. There will be some loud bangs. If you guys, I'll warn you when they're coming. But so I'm gonna just introduce the crew real quick. Got Chad Toulouse over here, my partner out of Boy Service Center. We take care of this area, Peters, out to Robinson, Mount Lebanon, Austin out of Washington, Chris Lau out of Washington also. We're all substation electricians. We deal with basically stuff inside the fence. So as you can see, these guys are geared up right now. Rubber boots, rubber gloves, sleeves, hard hat, FR clothing. This is stuff that we normally wear when we're handling anytime we're near any kind of energized conductors. So we get started here. I'm gonna have these guys, we're gonna energize a trailer, and I just want to briefly explain how we do it. You hear the generator running over there. Basically that generator is putting out 120, 240 volts to the bottom of that transformer right there on that first, Chad points out, coming out of them bushings right there, that's 120, 240 from the generator. That transformer doesn't really know anything other than it transforms. So it'll either step up or step down voltage. Usually on our lines, we take usually 7,200 volts and we step it down to 120, 240 to feed into your houses. So in this case, we're actually doing the opposite. We're gonna backfeed this transformer. So there's actually 7,200 volts up there. It's the real deal. And we go through the whole thing. You guys are out working, you hear generators running, people are out of power, lights are out, but you hear generators running. We've had problems in the past where people don't hook up their generators properly. We call them suicide cords. You got 2 male ends on an extension cord. Somebody plugs it into their generator, plugs it into their house. Well, you're just doing the same thing we just did. You're backfeeding your whole house through that panel box, through that meter socket, up to that transformer. 7,200 volts out on the line. So if you guys are out there working, you think the power's off, and all of a sudden somebody fires up a generator, could potentially backfeed that. So that's why we always have a licensed electrician do our hookups and everything. So we don't run into those issues. But we do. That's why we wear all our stuff and put our grounds up and all that stuff to protect ourselves. So as Chad goes ahead, he's going to close up that first fuse right there. That's a fuse cut out for that transformer. He's going to energize. Go ahead, Chris, step on that switch. So as Chad closed that up, you got 7,200 volts running there. You got your strains, insulators. Basically, that's how we run everything. We keep, even on the wood poles and everything, insulators. Electricity is always looking for a path to ground. Our job is to keep it from going to ground. So that's when trees and everything else fall into it. So 7,200 volts goes into the top of that transformer on the second one, 120, 240 coming down through that underground service and feeds our first house. Right through the meter. So yeah, the trailer's only 30 foot long, but usually our lines run for miles and miles and miles. So you might have 50 to 100 cutouts on a line. A lot of people hear during a storm or something, you hear a big bang out there and everybody's like, oh man, the transformer blew up. Well, it's rarely the transformer that blows up. It's usually the fuse, and you guys will get to hear it here in a little bit. That's usually the noise you'll hear in the bang. So, still running down. Got our primary still running down. We hit our next sectionalizing fuse. Same thing, it's sectionalizing power. So as Chad closes that in, you see the house light come on. Through our open secondary wire, most people have this go into their house. You either have a piece of triplex or an open 3-wire secondary. Feeds the overhead mast to that meter socket, powers up that light. So basically, got the whole trailer energized. It's a normal day out there. And Chad's gonna grab the squirrel here and he's gonna put it up on a line. You guys all heard bird on the wire. So as he puts that thing up there, that squirrel is just no different than a bird. He's not grounded, he's not shorted to anything. But the second he gets off and he onto that steel pole, now he grounds himself. That electricity, like I said, is looking for ground. So go ahead, Chad, run her down. You're gonna hear a little bang here. See a little arc. That's what you hear out on the line. And everybody's calling in right now going, oh, a transformer just blew up. Well, we just killed the squirrel. So at this point, you notice, here, go ahead and step on that switch for me, bud. You got your light off here, your light on there. That squirrel, instead of taking out power to the 1,500 customers that might be on that line, it sectionalized it to maybe 1 customer, 10 customers, 20 customers. These people at this point are calling in going, you know, some people might be like, my neighbor has power, but I don't. Well, that's why. That fuse right there sectionalized that piece of line right there. That line might run another mile down the road. So right now, fuse is open and removed, and these guys are going to put a kite string up there. So get people to fly kites near lines. You don't think they're conductive, but you get a wet line there. It's just a piece of nylon. I want you guys to watch that light on that house over there. Chris, good. Yeah, you're on. See that light coming on? That little piece of kite string right now is a conductor. It completed that circuit, powered up that transformer, and 120, 240 down to that light, and powered that light up. So we're going to take a tree branch right now, do the same thing. And this is where you guys are going to get more involved when you're out there cleaning up a mess and you got a major storm that just blew through. Everything's wet. So Chad's going to take that tree branch now. He's going to put it across. Same thing. That thing's conducting electricity right now. Same thing as the kite string, powering that up. So if you guys were out there on the road and say that squirrel knocked the line down, you guys are out there, chainsaws, high lifts, whatever, getting rid of stuff. All of a sudden the wind's blowing, tree branch blows over, across that, it completes the circuit. Something that you thought was de-energized may become energized, and you're the person on the end of that. You know, like I said, for us to even handle these down conductors, Chad's going to show you right now, we put a personal protective ground up. So as he shorts his line out, we would then be able to go out, gloves and sleeves, be able to handle that conductor that's on the ground, hand it up to the guy in the bucket. He's going to take it back up, sleeve that wire back up, and try to restore these customers. Now, if the same thing happened, that tree branch goes across that open cutout. Go ahead, Chad, show them now what happens. That light's not coming on. That tree branch is catching on fire. And it protects the guys down on the ground who are handling this conductor. So just always something to be aware of. You got a conductor laying on the ground. You have to use extreme caution. We tell everybody, don't handle any down conductors. Get a hold of us, 911, whatever. We'll get out there, especially if it's an emergency. You know, we do our best to try to get out there, but you guys are generally going to beat us there because, you know, you guys are in this area. So the same thing is it kind of explaining how our system works, where that people would call the power company and say, hey, look, I'm out of power. Troubleman comes down the road. He finds that line down on the ground. So he puts his personal protective ground up there. We call dispatch. We get on his clearance, and you know, he has help down there. We test the line for voltage. But you know, you do this to protect yourself. So Chad's gonna go ahead and close this fuse. You're gonna get another bang here. And just say somebody happened to close a fuse in on us. You get a couple seconds here. So instantly blows that fuse, protects the guys who are working on that line down on the ground. So the next thing we're going to do, guys, we're going to show you basically a vehicle accident. we'll get a car door here. We're gonna energize that car door at 7,200 volts. And you guys could run into this problem. You guys got dump trucks. You get one of the big triaxles, you get the bed up. This happens all the time. We get calls all the time. Guy puts the bed up right into the 7,200 volts, and all of a sudden now you're getting contact. And Chris, you can let off that switch. Truck starts smoking, it catches on fire. We try to tell everybody the best place for you to be is in the truck, in the vehicle. Usually it would blow the fuse down the line, wait for somebody to get there, get the lines off it. But if you're stuck and the thing catches on fire, you're not going to sit in a burning vehicle. You have to get out of that vehicle. So best way to do it is you get out, try not to touch any of the sides of the vehicle. Jump out 2 feet on the ground, keep them close together, and shuffle your feet very closely together. The reason is, as that voltage is on the ground, if this is 7,200 where this cone is, and 2 feet away is 5,000 volts, that's a difference of 2,200 volts. As you bridge that gap, you're now taking the 2,200 volts across your body. But if you shuffle your feet together or hop, you're mitigating that 2,200 volts difference and potential getting across your body. So just a thought, you know, best to stay in your vehicle, but like I said, it catches on fire, you need to get out. So Chad's going to show you right now, if that vehicle did become energized and EMS or whoever shows up and tries to get that person out of that vehicle, he's going to show you what happens here. Go ahead, Chris. As he reaches up to touch that vehicle door, you see what happens. You're now becoming that path to ground. So anytime there's a vehicle accident, you got wires on a car, we ask everybody to stay 30 feet away, get a hold of the right people, call 911, get us there as fast as we can. We will do whatever we can. If we have to cut every wire down around that car, we will. If we have to take out a whole substation, we will. You know, that's first and foremost, is to keep everybody safe. Right now we got an aluminum ladder. Chris, go ahead off that switch. Not sure if you guys have aluminum ladders that you use for your public works. This is the only one we have in West Penn Power, and it's only for this display because they are extremely conductive. We just had an incident the other day, or a couple weeks ago in Canonsburg. Handyman grabbed a 40-foot extension ladder, threw it up, and right into the power line. He was killed. So always got to look up above. You get a 40-foot extension ladder, even closed is probably, 22 feet. It's pretty high, you're carrying it up. Even if it gets into secondary or the primary, you know, it's real bad. So Chad's going to show you right now. He's going to lean that ladder in. Chris, go ahead. You can energize it. That thing touches off. You being the person on the other end of that ladder, Chad's got an 8-foot fiberglass stick, which is isolating him from it, and his gloves and sleeves. But you don't want to be on the end of that. You will be the path to ground, and more than likely, anytime this happens, it's a fatal injury. So right now we got the dig-in box, and what we like to do is, you guys are always doing stuff around the townships and stuff, digging, you got your backhoes, whatever, call 811. You know, they'll get somebody out there, they'll mark all our underground utilities, and now, you know, all these housing plans, everything's underground. So you guys are constantly going to be digging around near our facilities. So 811 is the important thing to call. Get it checked out, make sure everything's safe. What we have here is a fireman's boot on.
It's off right now.
And a lot of our firemen and everything, they think we have rubber boots too. But one hole in that rubber boot, which is what's in that boot right now, and Chad's going to lean it in there. Good, Chris. As Chad leans that in there, this is where your step and touch potential come in. I'll move out of the way here. That's one little pinhole inside that boot, and 7,200 volts will find it like that. So once again, you're taking that step across, bridging that gap. That's the results that are going to happen. Next we got just a wooden stake here. A lot of people, I've been out on calls and guys I see the wire pushed off their driveway, and I'm like, you know, how'd that happen? Oh, I took a 2x4 and I, you know, shoveled it off. Well, that 2x4 is wet or dirty, it's going to track, and as Chad's going to show you right now, he's going to dip that in there, and you'll see what it does. So just a little bit of water on that wood, it instantly becomes a conductor. Same thing, you're on the end of a 8-foot 2x4, you're trying to shovel that wire off, and it becomes energized. Once again, you're the guy standing on the end of that stick. You will be the path to ground. So now we got a shovel here, basically the same thing. We got a steel shovel, Chris is going to energize. You guys get to see the same thing. That's why we call that 811. You stick that shovel in there. Once again, that shovel found 7,200 volts. You don't want to be the guy on it, even though it's got a fiberglass handle. It can still track down. Right behind that, we got a pad mount transformer. You guys see these in these lot plans a lot. Always want to make sure there's a lock on them. They're closed up. They do get old, rusty. Sometimes you'll see holes in them. See it, call it in. We'll get them changed out. It's hard for us to search it and check every single one, but after a few years, salt and everything else that hits them, they start to corrode and get holes in them. So you definitely want to stay away from those. Try to stay back. Don't plant stuff in front of them. All that good stuff. But yeah, like I said, if you guys take anything from this, so you see a live wire or you see any wire laying on the ground, doesn't matter if it's bell line, anything. Try to stay away from it. Even the bell lines can become energized on our facilities. They're all running on the same pole. Guy wires. You guys see guy wires all the time. Guy wire could flip up around the primary and be hanging off the ground. You guys know that farm on Burnside, you Cecil guys. They had a big bull in there, right in that field where they have all the llamas and everything. And the guy wire flipped up over the primary and was hanging about this high. And that bull went right over to it and licked it, and boom. Dropped them. They were not happy. So something like that, it literally is hanging up in the air and just floating there, and it's energized. Same thing when you get to, just like we're sitting on this, I know it's a wooden thing right now, but guardrails. Same thing, guardrail can become energized. You guys get to a job or whatever, just kind of look around, make sure there's no wires down, keep yourself safe, and like I said, you take anything from it, you know, don't handle down conductors. They can become energized at any point in time. You know, during major storms, we might be trying circuits out of the substation. You just don't know when something becomes energized. So the best thing you can do, stay 30 feet away, leave those down conductors down, get a hold of 911. They will get a hold of us and they will send somebody out as fast as possible. All right, guys, thank you.
Thank you.